Today's lesson is about solving rational equations, which basically just means we're solving equations that happen to have fractions in them. So if we look at this equation here of x over 3 equals 2, a more basic one than what we're actually working towards, but same idea. What basically our whole concept for this lesson is going to be is most people prefer not to deal with fractions when they can. So our goal is we're going to try and get rid of the fractions so that we can just solve a more normal equation. So like in this case, for example, if you are wanting to get x by itself, the way to do that would be to multiply by 3. The reason why that works is remember that a fraction bar is the same thing as division. So when we say x over 3, when we have a fraction of x over 3, what's really happening is x divided by 3. So if we multiply by 3, since multiplication is the inverse of division, these 3's cancel each other out, right? 3 divided by 3 is 1, cancels out, leaving us with just x on this side, and then 2 times 3 gives us the final answer of x equals 6. Right, that is certainly something that you have done before. So if we think about that, let's talk about if we had an equation like this. We have 1 over x plus 2 over x equals 1 over 6. Let's say we had an equation like that. So obviously we have fractions here, and like I said, if we have fractions, what our goal is basically going to be is we want to try and get rid of those fractions so that it's not as tough to solve, because I recognize that fractions can tend to freak people out sometimes. Well, the difference is there's not one thing for us to multiply by that cancels out all of our fractions because we have different denominators. So before we can get rid of our fractions, what we're going to need to do is get a common denominator with all three of our terms here. Kind of like what we did when we were adding and subtracting rational expressions in the previous section. You should go watch those video notes if you need to refresh. So when I look here, I see that I have two fractions with denominators of x, and I have one fraction with a denominator of 6. So to my eyes, a common denominator for this would be to get every single fraction to 6x in their denominator. So if we want to do that, if I look at 1 over x, we know we can multiply by stuff to change our denominator. The question is, what do I need to multiply by to get from x to a least common denominator of 6x? Well, x times 6 would certainly give us 6x. But obviously we can't just randomly multiply by 6. If we're going to multiply by 6, we need to do it on both top and bottom, numerator and denominator, because that way we aren't changing the actual value. Same thing with 2 over x. If I want to get that fraction to 6x, then I would need to multiply that by 6 over 6 as well. And then finally, if we look at 1/6, 1 over 6, if I want to get that to 6x in the denominator, well, we already have the 6, we would need to multiply the x into it. But again, we'd have to multiply by x on top and bottom, numerator and denominator. So, if I look at my first fraction, looking right over here, 1 times 6 is 6, x times 6 is 6x, like we said. We would then add that to whatever we get from the second multiplication here. 2 times 6 is 12, x times 6 is 6x. And then that would be equal to whatever we get from our third multiplication here. 1 times x is x, and 6 times x is 6x. So see now how we have created this new equation where we've just modified the original one. It still has the same values, but we have modified the original equation to where now all three of our terms have the exact same denominator of 6x. And so now what I'm going to do is much like the very first example when we were dividing by 3, so I multiplied by 3, I'm going to multiply this entire equation by 6x. And the usefulness of that is since every single one of these terms has a denominator of 6x, Well, when I take 6x times this first fraction, the 6x's will just cancel out, right? This 6x and the other 6x will just cancel out. Then whenever I take this 6x times 12 over 6x, again, the 6x just cancels out. And again, when I take it times x over 6x, it just cancels out, meaning we are left with simply 6 plus 12 equals x. Or in other words, if you can get every term in your equation to have exactly the same denominator, then you can effectively just solve the numerators, just solve the top, and you can just ignore, you can cancel out everything in the denominator, everything in the bottom. And obviously this is a very simple equation for us now. 6 plus 12 is 18, so x equals 18, and that's all we have to do.